Hello everyone. Today I'm going to present a math problem in AMC 12. This is a problem number 20 in AMC 12B in the year of 2024. It involves trigonometry, algebra, and function. I'm going to take two different approaches to solve the problems. Both approaches are worth learning. First, let's see the problems. Suppose A, B, and C are points in the plane with AB equals 40 and AC equals 42. Let x be the length of the line segment from A to the midpoint of BC. Define a function fx to be the area of the triangle ABC. Then the domain of the function is an open interval from P to Q. And the maximum value r of the function occurs at x equals s. What is the value of p plus q plus r plus s? We must understand the problem 100% before we try to solve it. Let's first draw the triangle ABC. We assume M is the midpoint of BC. Let's extend AM all the way to D so that MD equals AM, which is X. Then we connect D with C. Fx represents the area of the triangle ABC. PQ is the open interval for the domain of the function. R is the maximum value that is achieved by the function. When does it achieve the maximum? That is when x equals s. The goal of the problem is to find the value of p plus q plus r plus s. Any questions so far? You see a lot of information given by this problem, right? But if you are detail-minded, or if you are careful enough, you should have no difficulty to understand the given information and also the goal of this problem. We already explained M is the midpoint of BC. It is also the midpoint of AD. Now, let's look at the triangle ACD. This triangle has three sides, 40, 42, and a double X, right? Perhaps you may ask, I don't understand why CD is also 40. Well, let me explain. Let's compare two triangles ABM and DMC. Since M is the midpoint of BC and AD, therefore the two triangles have the same lengths in their two sides. Furthermore, the angle AMB and DMC are so-called vertical angles. They are equal. According to SAS rule, these two triangles are congruent, which means DC equals AB. In any triangle, the difference between any two sides is always less than the other side. Any side is always less than the sum of the other two sides. That's why we have the red number 1. You see the screen, red number 1? Simplify this. We get x is greater than 1 but less than 41. So P equals 1 and Q equals 41. If you have a rigorous mind, you may challenge me on this. You may say, wait a moment, this does not justify that P equals 1 and Q equals 41. You are right. I'm not going into details to justify this now. However, in my second approach, you will see that the values of P and Q are justified. Now, let's look at the red number 2. Can anyone tell me why? Is this obvious? Yes, it is. Remember, the formula for the area of a triangle it is equal to half of the product of its two sides times sine value of the angle in between, right? See the formula at the bottom of the screen. That's why we have the red number 2. Since the maximum value of sine is 1, therefore r, the maximum value of the function, is 840, which is achieved when the angle BAC equals 90 degrees. If the angle BAC is 90, then the angle ACD is also 90 degrees. Does anyone know why? Think about it. According to Pythagorean theorem, we have the square of the 2x equals the square of 40 plus the square of 42. Solving this equation, we get x equals 29. Therefore, s equals 29. Now we have the values for P, Q, R, and S. We add all them up and get 911. This is the final answer. Now let's take a trigonometric approach. We place our triangles in XY coordinate plane. Put A as the orange and B as the B0. Let's assume that the angle BAC is theta. Therefore, the vertex C would be at C times cosine theta and C times sine theta. So that's the coordinate of the C, of the vertex C. We can easily calculate the coordinates of the midpoint of M. Once we have the coordinates of M, we can easily calculate x, which is the square root of the square of b plus c cosine theta divided by 2 plus the square of c times sine theta divided by 2. After simplification, we get the square root of c squared plus 2bc times cosine theta plus b squared divided by 2. The maximum value and minimum value of cosine theta are 1 and -1. Therefore, we derive the range of x, which is between 1 and 41. But x never reaches 1 and 41. If it reaches 1 or 41, ABC would not be a triangle. This shows a rigorous proof of the value of P and Q. Since the function fx is the area of the triangle ABC, it is equal to the half times 40 times 42 times sine theta. Clearly, sine theta takes the maximum value 1 when theta is 90 degrees. So the maximum value of the function fx would be 20 times 40, which is 20 times 42, which is 840. The hypotenuse of the right triangle ACD is 2x. Therefore, the square of 2x is equal to the square of 40 plus the square of 42. Solving this equation, we get x equals 29. Therefore, s equals 29. Now, let's put everything together. We get our final answer, P plus Q plus R plus S equals 911. That's the final answer.